Good day, class. Today we're going to discuss the normal curve and standard scores. For our objective, we're going to describe the typical characteristic of normal curve, define z-score, compute the z-score for row score given the row score, the mean and standard deviation of the distribution. We're going to compute the score for a row score given the row score and the distribution of row scores. Explain the three main features of the standard. The second slide tells us about the equation of the normal curve distribution. Now here we have figure 5.1. The inflection points are located where the curve changes from being convex downward to being convex upward. If the bell-shaped curve is a normal curve, the inflection points, here is the inflection points, are one standard deviation from the mean Note also that as the curve approaches the horizontal axis, it is slowly changing its y value. Theoretically, the curve never quite reaches the axis. It approaches the horizontal axis and gets closer and closer to it, but it never quite touches it. The curve is said to be asymptotic to the horizontal axis. The next table shows figure 5.2, which are areas under the normal curve for selected scores. Now, notice that the population is 100 and the standard deviation is 16. So here is the population 100, and on the right side is the one positive standard deviation, two and three positive standard deviation, and on the left side you have the negative standard deviation, 1, 2, and 3. You have certain percentages from the mean up to the standard deviations of each side, so that one standard deviation from the mean going to the right is 34.13%, and going to the left it's also 34.13% from the mean to one negative standard deviation. Suppose someone told you your IQ is 132. Would you be happy or sad? In the absence of additional information, it is difficult to say. An IQ of 132 is meaningless unless you have a reference group to compare against. Without such group, you can tell whether the score is high, average, or low. For the sake of this illustration, let us assume your score is one of the 10,000 scores of the distribution just described. Now we can begin to give your IQ score of 132 some meaning. For example, we can determine the percentage of scores in the distribution that are lower than 132. Referring to figure 5.2, we can see that 132 is two standard deviation above the mean. In a normal curve, there are 34.13 plus 13.59 equals 47.72% of the scores between the mean and a score that is two standard deviations above the mean. To find the percentile rank of 132, we need to add to this percentage the 50% that lie below the mean. Thus, 97.72% is equals to 47.72 plus 50% of the scores fall below your IQ score of 132. You should be quite happy to be so intelligent. The solution is shown in figure 5.3. Figure 5.3 shows us the percentile rank of an IQ of 132. So 132 is two standard deviation from the mean. So you try to add 50% plus 47.72%, that equals 97.72%, which means the percentile rank of 132 is 97.72. A standard score is a transform score that designates how many standard deviation units the corresponding row score is above or below the mean. In an equation form, standard score is equivalent to the score minus the population mean over the standard deviation. Or standard deviation or the standard score is equivalent to the score minus the mean over the sample population or the sample data, standard score for sample data. So from the previous example, standard score is equivalent to the score minus the population mean over the standard deviation, replaced by numbers. It's 132 minus 100 over 16. The answer is 2. Next, we have the standard score is equivalent to the score minus the population mean over the standard deviation, 340 minus 300 over 20, which is the standard deviation, which means that the standard score is 2. Now here is the percentile rank of 34 of 340. So that's 50% plus the 47.42% is 97.72%, which means 340 is 2 standard deviation above the mean. So 97.72% have an IQ below 340. So next slide, we have a practice problem 5.1 for the set of examples sample scores. The scores are 1, 4, 5, 7, 8. Determine the standard score for each row score. So the first step is to determine the mean of the row score, and the second step is to determine the standard deviation of the score using these formulas. Okay, the characteristic of standard score. The standard score has the same shape as the set of row scores. The mean of the standard score always equals 0. Standard deviation of standard score always equals 1. So finding the area given the row score. So here we have the standard score is equivalent to the score minus the population mean over the standard deviation equals 142 minus 100 over the standard deviation 16. So the distance between the mean, which is 100, going to the two standard deviation is the standard deviation is 16. So that 42 over 16 is equivalent to 2.62 is the standard score. So the next slide is another practice problem. So you have here the solution for this problem, and then another slide would tell us another practice problem, which is practice problem 5.3. Okay, so here another table that shows us finding the row score given the area. And that is all for our presentation for today, and thank you.